one up here. And it is written this way. I want to give you a few math terms. Okay, so the big number here, or the number that's regular size, we call that the base. We call that the base, and the base is a factor. And whenever we're talking about factors in math, we're thinking multiply. It's a factor that we're going to multiply again and again. Now that 3 is written, and we call this, it's written in superscript. Okay, I'm going to use a different color because blue is no longer good. 3 is written as a superscript, and that means that it's written above the number and it's a little bit smaller. Later in math, you will get used to seeing a subscript, sub below the number below. But for right now in this year, we're going to be talking only about the exponent written as a superscript, and it is called the exponent itself. And it tells us how many times we're going to use the base. It tells the number of times we're going to use the base as a factor. Use the base, and I'm going to change that word base to red because I want you to be thinking about it as it is that number there. The base as a factor. It's shorthand. It's a way of showing something shorthand. Just like mathematicians always thinking about another way, just like if I was going to say 4 plus 4 plus 4, a shorthand for writing all of that would say what? 4 times 3. I have 3 of them. This is also a shorthand. Instead of saying 4 times 4 times 4, I'm using that base as a factor, factor multiply, and factor 3 times, 1, 2, 3. I can just say that's the same as 4 to the 3rd power. This is a lot easier to write, or a lot smaller to write than this. And maybe not so much of a big deal when that exponent is 3, but that exponent can be any number. It can be 100. And I wouldn't want to write 4 times 4 100 times down here. It could be 50, it could be 15. So it's a number that tells me how many times I'm using that base as a factor. So, and then I can evaluate that exponent, which means if I wanted to evaluate or find the number, I know that 4 to the 3rd power, and that's what we would say. We would say it's 4 to the 3rd power is how I would say it. I would read that as 4 to the 3rd power. What I'm thinking that it means is 4 times 4 times 4. And I know these are all numbers, so it does have an equivalent term that's one number. And how I figure that out? Well, 4 times 4 is 16. Times 4 again, 16 times 4. Well, 10 times, if I think of 16 as 10 plus 6, 4 times 10 is 40. 4 times 6 is 6, 12, 18, 24. So that would be 64. So 4 to the 3rd is 4 times 4 times 4, and it is also 64. All of those things are equivalent. That's why they have the equal sign there. Okay? So it's a shorthand and easier way to do it. So in your book, if I had something written down, like some of the examples you're doing today, if I had something written down as 10 times 10 times 10 times 10 times 10, in exponent form, I would write it as 10. That's the number I'm repeatedly multiplying. That's the factor I'm using. How many times? 1, 2, 3, 4, 5. 10 to the 5th power. And then I could also figure out what numerical number that is. 10 times 10 is 100. times 10 again would give me 1,000 times 10 again. Make sure I'm bringing them all down, which is 10,000 times 10 again. And for 10, 1, 2, 3, 4, 5, 1, 2, 3, 4. It's the number of zeros after there. That's just a special thing about the number 10. I would still, what I'm doing is I'm multiplying, then taking another one, then taking that answer times the other one, and that answer times the other one. There is a key on your calculator a little bit later in the week. I can show you how that works too for checking.
So it's the number of times that you move the decimal point one place to the right because it's a base 10 system.
So there's some important things to know about exponents. So if I said 10 to the 5th power, it's 10 5 times. If I said 2 to the 3rd power, what would that be? That would be the base, which is 2. I'm going to multiply it by itself 3 times. I need 3 2s. I need 3 of them. I need 3 2s. So 2 times 2 is 4. Times 2 again is 8. The other thing we want to think about is anything raised to the 1st power is just itself. I'm going to use 2 as a factor 1 time. So that's just 2. Any number written to the 1st power is just that number. Now notice I can put any number as a factor. I can use a fraction. I can use a decimal. When I use a fraction, it's important you put the parentheses around it because I might then assume that it only applies to the 1st number and not to the bottom number. So when you see a fraction, you'll see that parentheses around it, meaning both terms, the numerator and the denominator, are being used as a factor because I'm using that fraction, not just the top term. Any number, 367 to the, and 7/10 to the 1st power is 367 and 7/10. I'm only using it 1 time. That's one of my favorite ones to know. The other one is
move a little to the left. Thank you.
Anything raised to the 0 power, and it's to the 3rd power or to the 0 power. We would say here it's raised to the 1st power, or I would say here to the 0 power is the number 1. I'm not using that base anytime, it's the number 1. Any number, again, 3/4 raised to the 0 power is 1. My 367 to the 0 power is 1. Right now, you are dealing with positive numbers in exponents. Later in your mathematical career, you'll talk about negative numbers to exponents. But for right now, we're just talking about positive terms, and it's those number of times. So these are the big ones to remember. So I can go back and forth with exponents. I could be given a number, like, trying to find an example from the book. Okay, I could be given a number like this, 1 1/10 to the 2nd power, and your book says, find the value. So what is that? Well, what does it mean first? 1 1/10 times 1 1/10, and I need to find that out. So 1 1/10 times 1 1/10, 1 times 1, 1 times 1. Now it's 10, I'm in 2nd place, times 1 again. And I have 1, 2 places. So the value of that is 1 21/100. I could find out what, I want to find out a different one. How about 7 to the 4th power? I'm looking right off the guided practice today. 7 times 7, 4. I need 4 of those bases. I like using the word of because it reminds me I'm multiplying. And now I'm thinking about, okay, how can I simplify that? 7 times 7 is 49.
They're all playing video games.
And this 7 times 7 is 49. So it's really 49 times 49. It's going to be a big number. It's going to be a big guy. 49 times 49. 2,401. Okay. So that's a good one. I want to show you something on the calculator. So if I perfect. Look at this is my phone. If I turn my phone, I get a scientific calculator. Now it's mirror wrong for me. If I wanted to check my answer, there is a square root key on here. I'm finding it. Hold on.
Does that happen on every calculator?
It does when you turn it. So see that button there that says x to the y power? You see the little button that says x to the y power? So if I put in 2 and I hit x to the y power and I put in 6, it should tell me what 2 to the 6th power is. 2 times 2 times 2, 6 times. Let's do one we already know, like 4 to the 3rd power. If I type in 4 and then do x to the y power and then type in 3 and I hit equal, it gives me 64. It's a way to check your work. So if you turn your phone, you'll get what we call the scientific calculator, and that's what you want. And you see it already has buttons like x squared and x to the cube power, the squared power, the 2nd power, and the 3rd power. It already has that. Again, 2 and 3 have some side names. I can say it's to the 3rd power, or I can say it's cubed. Why? Because a cube has 3 sides that would be the same. I could say cubed, or if I had something to the 2nd power, I would say that that number is squared. I could say it's to the 2nd power, or I could say it's squared, again, because that square is a special math term too. But we don't say it for any other dimension. To the 4th power, we say the 4th. To the 5th, we say the 5th. So it's just kind of a neat thing to try out. You can try out a few things there.
All right, and that is the way that you find exponents.